Hello, this is Justin Nelson with CGJJ Engineering Solutions. We are thrilled to provide plans for Phase 4 of the UCSD Hillcrest Hospital Reconstruction Project. Additionally, we will be enthusiastically committed to our continued relationship with UCSD Health beyond final completion. For this project, I developed demolition plans and assisted in decisions with stormwater quality management. Primary focuses throughout demolition were determining which existing conditions could either be protected or made for reuse. The existing cold water cooling network and some of the stormwater utilities on site are some main examples of items we deemed reusable. Especially with demolition, designing our project to be LEED Gold was paramount. So for stormwater management, we determined on adding 3 bioretention basins site-wide and a bioswale underneath the NARF building by Dickinson Street. The bioswale would aid in collecting stormwater and filtering it due to the lack of existing drainage inlets, and the bioretention basins would help with stormwater management on site.
Hello, my name is Josh Jokes. I completed the geotechnical investigation for the UCSD Hillcrest Hospital redevelopment for Team 18. For the geotechnical overview, we have 3 items. First, we have the findings that we acquired through our geotechnical investigation. Second, we have the potential issues we must design for. Third is the recommendation for mitigation to solve the potential issues. Through our geotechnical investigations, we found that our site is underlain by 3 soil types: fill, Mission Valley Formation, and Pomerano Formation. In this historical boring, you can see up to 15 feet of fill, but this is only one point on the site, which means we are assuming that the depth is varying over the entirety of the site. What are the potential issues that we can face on this site? We have 3 potential issues we can face. First, we have liquefaction. Second, we have expansive soils. And third, we have compressible soils. Liquefaction typically occurs in cohesionless, loose sands that are saturated. In this case, liquefaction is not an issue, as our site has soil that has cohesion, is dense, and the groundwater is very low. Expansive soils have the potential to cause heaving on the structure, but in this case, expansive soils are not a threat, as the boring logs show no evidence of potential expansive material. Our third potential issue and most prevalent is compressible soils. Compressible soils are typically found in fill and generally experience a large amount of settlement. In this case, compressible soils are what we will aim to mitigate. Differential settlement is a direct cause of varying depths of compressible soils throughout the site. Our recommendation for mitigation against differential settlement is as follows. The subgrade below the hospital should be over-excavated 5 feet in depth and backfilled with engineered fill. This engineered material will reduce the potential of differential settlement and should provide a uniform settlement for the hospital.
My name is Cesar Cabrera IV, and I'm the structural engineer responsible for ensuring the seismic safety of the UCSD Hillcrest Hospital in accordance with California standards. I'm here today to share insights into some of the critical decisions made during the design and construction of the hospital's structure. The hospital site is located on a local bluff, exposing it to windy conditions, which we need to consider when calculating the total factored load. Data for this analysis was supplemented by real-time forecasts provided by NOAA. All external factors were considered negligible. Additionally, geotechnical investigation and grading conducted by geotechnical engineer Josh Jokes indicated that conventional shallow foundations are viable for the proposed subsurface conditions. In designing the hospital, we adhered to several codes including the ACI 318, the Steel Construction Manual, and the CBC. These codes provide essential guidance for ensuring the seismic safety as well as overall stability and durability. CGJJ Engineering Solutions recommended constructing the hospital with a steel shell, providing optimal resistance against seismic activity while also accommodating additional loads due to unforeseen events like windy conditions. Based on their recommendations, the structural elements of the hospital were designed as follows. 4 5x5x2 footing slabs with 4 number 8 bars and 3.25 feet spacing, 20 7x7x2 footing slabs with 6 8 bars and 1.95 feet spacing, 21 10x10x2 footing slabs with 8 number 8 bars and 1.39 feet spacing, steel column height set at 14 feet. Also, finally, 4 chevron braces recommended for shear resistance. The hospital designs incorporates a steel shell, chevron bracing, and coupled shear walls to address the unique challenges at its location. These decisions were made with adherence to California standards and industry best practices such as ACI 318, the Steel Construction Manual, and the CBC, ensuring the hospital remains safe and functional during any potential seismic activities and other environmental conditions.
Hello, my name is Georgi Gonzalez, and I am Water Resources Engineer for CGJJ Engineering Solutions. I'll start talking with stormwater and drainage analysis for our project side. Our team decided to use rational method for our analysis. We have divided project site into 3 different basins: Basin A, Basin B, and Basin C. Due to the peak flow analysis, we have suggested 3 types of pipe for each basin. Dimensions for these pipes are 16, 14, and 19 inches of PVC pipes, and these pipe sizes are minimum requirement. For water and wastewater studies, CGJJ Engineering Solution has determined water demand for the hospital. For our project, it was 90,872 gallons per day for indoor water use. And our team have suggested 2 types of pipes to handle that requirement. For the potable water, our team suggested 2.5 inches PVC pipe, and for fire flow, our team suggested 4-inch PVC pipe. For wastewater, our team has estimated that peak discharge flow rate for the worst case scenario would be 93,098.3 GPD. And according to the information, our team suggested that 0 main should be 10-inch PVC pipe. On the site, there was already existing 10-inch pipe, and our team gave recommendation to use existing one and check its conditions. Thank you for your time and for your attention.